hello everyone. Hope you are doing well. So it's time for group 5 to shine. So there are Bunchong, Daryl, Jared, Patricia, and Sean. So we will present our work for the past 2 weeks. So I will explain the problem statement that we take. So we chose problem statement 2. Let me explain what's inside. So usually the CCA was conducted offline. Then the coronavirus came. And now the CCA is conducted online because of the coronavirus. Well, this gives us a lot of advantages, and one of them is the easier to register for various activities. And of course, as a result, the total sign-ups increase a lot. However, in the end, the total event attendance, only almost half of them didn't show up. So let's summarize it. So firstly, online activities, it gives us the easier to register for various activities and the total sign-ups increase. However, in the end, most of them not show up. And this one also happens in DAC. This is a problem, but don't worry, let's see what we can do. Sean will explain to you in the next slide.
Thank you, Patricia. The way we have structured our project actually can be done quite quickly. Even right after this, this whole entire showcase, the DAC can actually adopt this. So in case you want to pick this up, just send us a message. So firstly, we generate our data. For this case, our data is randomly sampled. Next, we'll process our data, we'll explore our data. Finally, we'll do some prediction and ranking of our attendance using a supervised classification model. And lastly, to evaluate the DAC, we'll do some clustering so that we can better not only just predict whether people will turn up, but also improve the attendance as a whole. Next. Next. Okay, as the famous saying goes, your model is only as good as your data. A back one, Patricia?
Sorry?
Yeah, okay, this is great. Yeah, as I said, as the famous saying goes, your model is only as great as your data. So on the right, on the left-hand side, you can see your SIM your name, your school, your courses and positions. All these data are already available to DAC. And most of it actually come in the form of the registration data form that was done prior to you joining to DAC. So these are already data relevant to us. We can also take some survey samples, the number of CCA, for example. And we have taken 200 data points for this project. This is reference from the number of members in the DAC group chat. Next. Okay, yeah, so finally, we'll do some data processing. On the left-hand side, you can see us doing some data cleaning to make sure our data is quality. And on the right-hand side, we'll do some feature engineering because we realize that students that join later will tend to have a bigger SIMID. And we can actually use this data to we can actually transform this data as a relevant feature in the future for our machine learning. So as you can see, we scaled and transform our SIMID to our relative registered duration. And we will be using this for our ML model next. I will now hand over to Jared because one of our members is not around, so we'll skip this part. Yeah. Over to you, Jared.
Thank you, Sean. So for the supervised learning part, we'll be using 5 different classification models. And we pick logistic regression as our baseline model, meaning that the other 4 models, right, they will actually have to try to outperform the logistic regression model. Next slide. Yep, so for the logistic regression, the model actually came out with an accuracy score of 0.8. This means that the model is actually able to predict 80% of its predictions correct. So let me just briefly explain how you read the confusion matrix. Basically, what it plots is it plots the actual, against the predicted outcomes that the model has given. So 0 would mean that the person did not turn up for the event, and 1 would be the person has turned up for the event. So for example, do you see the number 26? This means that the model has predicted that the member will turn up for the event, and in actual fact, the member did turn up. Next slide. Next slide. I think you skipped one. Yes, the model that we have chosen is the XGBoost. It gave us the highest accuracy of 0.85%, which is 85%. Next. So we also use the model in order to predict the probability of attendance and then rank the members accordingly. So what you see at the table below is actually the top 5 members who has the highest probability of attendance. All right, next. Next, I'll pass my time to Boon Chong.
Hello. Okay, so thank you, Gerald. So for unsupervised machine learning, we plotted a scatter plot with k-means and db-scan, which is shown in the slides here. With k-means and db-scan, we found several clusters within our dataset. For example, one of the clusters we found consisted mainly of business students with multiple CCAs. For this case, we will recommend DAC to consider targeting them by conducting less technical courses with flexible timing to cater to them, whereas the ones with lower CCA counts and in a technical course will be more likely to appreciate more in-depth technical courses that are catered for them. So in order to do better analysis, we'll recommend gathering more information from the participants or via the school. Some of which we recommend is like collecting the time where the participants check in or out of school for the lessons. Although this might not be possible, then you can ask them to do like when they're doing a survey at the end, you can ask them to check what time are their classes, and then we can see, because it's more likely for a student with classes that end at 6 p.m. to attend our night classes, night workshops than a student with that end his class at 12 p.m. Yeah, and with that, that's it for our presentation.